Okay, good evening. Can you hear me?
Yes, sir.
Yeah. Okay, thank you. Okay, last week, before that, before we start, I need who didn't receive our tute. Part of the Hambud this tute forces and its behaviors. This tute. Hashini, okay. Hashini, Midum, Shivan. Shivan, I posted. Sindhu. Ashini, okay, I posted yesterday. Medium Vidya. Xenon, I posted SRMO Wednesday. මේ ඔක්කොම මම රසින්දු yeah 22 tube specs I posted Wednesday and only 4 tube specs Friday. You can check tomorrow morning, right? Tomorrow morning in your post office. Okay, no problem. Today lesson we can continue. Today we discuss in Newton's law. I'll give you short note. No problem. Hi. Okay. Hi. Okay, last week we discussed Newton's law finally, right? I told the content of the lesson. We have 8 main topics in first lesson. That's a very long and very bulk lesson. That's the main topic, main physics lesson in our physics lessons, in our grade 12 physics lessons. And we have 8 sub-contents, right? Subtopics. The first one is basics. Basic topics we discuss, basic things of force lesson. Basics of force. Basics. Right, basics. Basics of force that we already discussed, and Newton's law. Still we discuss in Newton's law. Newton's law. Newton's law. Third one. Third one is today our new topic is friction force. That's the main topic today we're discussing about friction force. Friction force. Friction force. Friction force. The next one is resultant force. Resultant force. Resultant force. Fifth one, moment of force. Sixth one, couple of force. Couple of forces. Finally, force equilibrium. Seventh one, force equilibrium. Force equilibrium. Okay, that's the other all subtopics we discussing under this lesson, right? Still we discuss basics of lesson, maybe basics of forces and some 50% of Newton's laws completed, right? Hi. Today, quickly let's try to complete Newton's law and complete move into the next third main topic, friction forces. Friction forces. All right. Okay. I hope you all complete written note, right? Written note very important this lesson. I gave you. I hope to give you written note, written short notes only for long lessons. Long lesson, not for all lessons. අපි දිග්ග lessons වලට අපි tute එකකින් විතරක් if we continue with only tute it will be very complicated. That's why I give you a short note and as well as tute both, right? Printed note and short note both. Okay, you all complete, right? May written note, if anyone didn't complete, raise hand. I mean short note, I will send you written note, then you can complete. If anyone not complete, එකනදී හරි මම දාන්නම් එක. Yeah. Okay. Now you can complete our check the Amishkas. Amishka, you have to watch the recording and complete the note. Did you collect tute? Amishka, did you collect tutes? ටියුට් එක හම්බුණා. මේ හම්බෙලානේ සමහර අයට තමයි හම්බෙලා නැත්තේ. Okay, go to recording and okay. Last week, finally we discussed about wait. Okay, last week finally we discussed about Newton's first law and second law. Hari. Okay, I'll revise again and let's move into the remaining parts. Hari. Okay, we discussed Newton's first law first. Okay, what's the meaning of Newton's first law? In the first law, Newton explained about balance object. Balance object. Newton explained about balance object, right? Newton's first law. Newton's first law. In the first law, Newton explained about balance object. Balance object means if there is no unbalanced force act on any object, if there is no unbalanced force means it's a balance object, right? 10 Newton, 10 Newton. It's a balance object. If there is no any unbalanced force act on object, if it is rest object, this object stays rest, no any moment, right? Stays rest. And if it is moving due to any reason, if this object moving, it's moving with how? With uniform velocity. If it is moving, the object moving with uniform velocity. Okay, that's a Newton's first law, very simple. In the first law, Newton explained about balance object. If there is no unbalanced force, if this object rests, it stays rest, and if it is moving with uniform velocity. In other direction, if you got rest or uniform velocity object, we can say they all rest and uniform velocity objects are balance objects, right? They were balance. ඒ කියන්නේ balance තියනවා නම් මේ විදිහට තමයි තියෙන්න පුළුවන්. If it is this type motion, rest or uniform velocity motion, they are balance object. Okay, this is Newton's first law. Very simple. Okay, in the second law, Newton's second law, he explained about unbalanced object. Simple. He explained about unbalanced object in the second law. Newton's second law. In this Newton's second law, Newton explained about unbalanced object. Unbalanced means there is an unbalanced force like this. There is an unbalanced force. එහෙම unbalanced force එකක් තියෙනවා. It has an unbalanced force. This is a mass m. Okay, Newton's second law we can explain by two main methods, right? We explain that. We can explain Newton's second law by two main methods. The first one is acceleration based method. I told if there is an unbalanced force, මෙහෙම ගමු තේරෙන විදියට. 20 Newton and 10 Newton. There is an unbalanced force, right? There is an unbalanced force. 10 Newton unbalanced force into this direction. Then definitely it has an acceleration. Definitely it has an acceleration. Yeah, if it is unbalanced object or if there is unbalanced force act on any object, the object accelerating. This is Newton's second law. The object accelerating. This acceleration directly proportional to the unbalanced force, and this acceleration act on this object inversely proportional to the mass. This is a Newton's second law based on acceleration method. Newton's second law based on acceleration method. Okay, according to these two relationships, we can get equation F equal ma making n, right? This is acceleration based method. Acceleration based method. Okay, we have another method. Another method, momentum based method. Do you remember what's the meaning of momentum? Do you remember what's the meaning of momentum, Asel? Momentum, P. Momentum. 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 What's the meaning of momentum? Yeah, it is equation, Ashmita. Mass into velocity is a momentum equation, that means calculation method. Yeah, very good. Yeah, the reluctance of any object to change the motion state, right? ඒ කියන්නේ අපි මේ වගේ move වෙන object එකක් ගත්තා. If you got this type moving object, the reluctance to stop this object, to reluctance to stop. I told the momentum depend on the two main factors, mass and velocity. Mass and velocity. Therefore, momentum. This last week lesson I explaining, right? Last week lesson. Last week absent I especially hagande. This momentum depend on two main factors. Two main factors, mass and velocity. Then mass into velocity, we can get the momentum. P equal mv. I'm explaining very short way. Or the full lesson එක බලන්න. You have to go through last week recording, right? I only revising important things. Okay. Then what is the unit of momentum? What's the unit of momentum? Unit of momentum. Unit of momentum. Anyone remember? The unit of momentum. The momentum unit. Very good. It is very simple. They are physics. No, you don't need to buy hard. Mass unit kilogram, velocity meters per second. Then kilogram meters per second is a momentum unit. Okay, how we can explain Newton's second law? Momentum based method. Momentum based method. Think Newton explained Newton's second law. The momentum based method is, think this is a straight line O. horizontal path, horizontal line, horizontal surface, right? Think this is a object, this is an object with mass m and velocity v. Velocity v. This is the same object after some displacement, same object with mass m and velocity v2. It's v1. V1, right? In the Newton's second law, in momentum-based method, Newton explained the unbalanced force act on any object. If there is an unbalanced force acting on any object, this unbalanced force is directly proportional to the Cartesian momentum change rate. Momentum change rate. Change rate. This unbalanced force equal to the, not equal, directly proportional to the momentum change rate. Momentum change rate means unbalanced force directly proportional to the momentum change rate mean momentum change. Momentum change mean actually final momentum, momentum minus initial momentum divide by time. Divide by time. It's short way, right? Recording balanda. Then final momentum mean mv2 minus mv1 divide by time, right? Then this equation also f inversely proportional m into v2 minus v1 mean velocity difference divide by time. The velocity difference divided by time equal to the acceleration, then f equal ma given by this equation as well. This equation also given f equal ma. Okay, this is a Newton's second law, acceleration based method and momentum based method. Momentum based method. Okay. Okay, I told if you got any linear motion object, linear motion mean like this, like vehicle motion, right? Linear motion object, it's four main motion types. Motion type mean motion states, right? The first one is rest objects. Rest objects, right? The second one is uniform velocity object. Uniform velocity object. Uniform velocity object. The third one is accelerating object. Accelerating object, and fourth one is decelerating object. Decelerating object. Okay, this is summary of Newton's first and second law, right? In the Newton's first law, Newton explained about balance object. If it is balanced, definitely it is rest object rest and moving object moving with uniform velocity. He explained about rest and uniform velocity objects, right? In the Newton's second law, Newton explained about unbalanced object, right? If it is unbalanced object definitely accelerating or decelerating. Then Newton's first law, Newton explained about balance object, rest or uniform velocity object. In the Newton's second law, he explained about unbalanced accelerating or decelerating objects. I got the full story. Any doubt you can ask now. If you have any doubt, you can ask now. This is a last week full summary. Shivan, Nitira, any doubt up to now? Hi. Okay, if you have tooth, tooth නැදත් අවුලක් නැහැ. No problem. Okay, get the answer for this question. First one. First one. An object. Before that, sorry. Before that, what is the Newton's second law common equation? Newton's second law, acceleration based method or momentum based method, you got common equation F equal ma, right? You got common equation F equal ma. Then what's the name of m? What's the name of m? What's the meaning of m? F equal ma equation. Rashmita. Good diet. It is mass. Mass. You know mass standard unit may mass. Mass standard unit kilogram, right? Mass standard unit kilogram. A mean A. A mean acceleration. Very good. Acceleration. 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 Very good. It is ms minus 2. Then what's the meaning of F? What's the meaning of F? Venuji. What's the meaning of F? F. Yeah, very good. Yeah. If you write it is force, we need wrong. It is not the force. Force can be. It is not the applied force, it is unbalanced force. Remember, it is unbalanced force. Unbalanced force, not the force. It is unbalanced force. Unbalanced force. Unbalanced force or මෙයාට අපි කියනවා resultant force also same thing. Resultant force. Resultant force. Resultant force. Okay, that we discussing in future topics. Resultant force may further discuss, right? Don't think. Now understand this. F is unbalanced force. Unbalanced force is actually the resultant force or net force also correct. Net force, good. Net force. Net force. Net force. Net force. Right. Okay, now go to the question number 1. Hari, answer එක දාන්න. හැමෝම හදන්න. ටියුට්ස් නැහැ කියලා ඉන්න එපා මේකෙන් බලන් හදන්න. This is a question. An object of mass 200 kilogram is an accelerating with 2.5 meters per square second acceleration. The unbalanced force that can act on this object is the unbalanced force that can act on this object is the unbalanced force asking. The question asks unbalanced force act on this object. The unbalanced force act on this object is asking. Okay, lot of answers. Very good. All are correct. Yeah, all are correct. Yeah. How to start this question? It is object accelerating. It on Newton's first law or second law. That you need to understand. The object is accelerating with 2.5 meters per square second. Then Newton's first law or second law? Yeah, definitely it is Newton's second law. Then you can, according to Newton's second law, the unbalanced force equal ma. Unbalanced force equal ma. Then mass of the object 200 kilogram. Acceleration of the object 2.5 meters per square second. Then 500. Actually, the unit is kgms minus 2 is a unit. But I told the new force unit is a derived SI unit. Derived SI unit means we can replace by another term. Okay, therefore 1 kg ms minus 2 equal to 1 Newton. Isaac Newton name එක part එකක් තමයි දාලා තියෙන්නේ, right? Then 500 kg ms minus 2 equal to 500 Newton. 500 Newton. 500 Newton. 500 Newton. Okay. Okay, question number 6. Can you send me the answer? Yeah. We have to buy scientific calculator, right? Yes. You have to get scientific calculator. I will send me all my exam accepted models into group. I have sent, I think, I'll send it. I'll forward it again. Yeah, very good. Answer second one. Very good. All are correct. Okay, which of the following force shown in the figure below will give greatest acceleration? Greatest acceleration mean it's Newton's second law. Newton's second law, you know, this acceleration and unbalanced force directly proportional, right? In the Newton's second law, this unbalanced force directly proportional to acceleration. So acceleration directly proportional to unbalanced force. What's the meaning? Increase in the unbalanced force, the acceleration also getting increased, right? That's the meaning. Then, okay, first answer. What is the unbalanced force? Unbalanced or resonant force? It is only 2 Newton into left side direction, 2 Newton unbalanced force. Second answer, It is 20 Newton unbalanced force into left side direction. Third answer, only 10 Newton unbalanced force into left side direction. 10 Newton unbalanced force into left side direction. This unbalanced force direction also very important, right? In future result force part I will explain, because this object accelerate into this unbalanced force direction. Unbalanced force direction. 12 Newton unbalanced force into left side direction. 12 Newton unbalanced force. What's the unbalanced force for final answer? Unbalanced force of final answer? Final answer, unbalanced force? Yeah, very good. The final answer, final answer unbalanced force 0. 0 Newton. Therefore, it is a balanced object, right? It is balanced. It is Newton's first law. Newton's first law. It's not accelerating. It is rest or uniform velocity object. Rest or uniform velocity object. Then the greatest unbalanced force giving greatest acceleration. Answer number 2. Greatest unbalanced force. Unbalanced force the greatest unbalanced force giving greatest acceleration. Right? Any doubt? Tisum? Midum? Are you clear? Okay. Any doubt? Clear, right? Hi. Let's move into next question. Okay, question number 7. What's the answer? Question number 7. What is the following unit of the momentum? Momentum, very simple question. It's a fact. It's a theory. What's the following unit of momentum? What's the answer? Yeah, very good. Answer number 3. kgms minus 1. kgms minus 1. Okay, this is a question. A car with mass 900 kilogram, a car with mass 900 kilogram is moving along a straight line accelerate from rest to speed up to 12 meters per second within 8 seconds. The force required for this, the force O, F tamahan. The question is, what is the value of F? Hadam, get the answer. Very good, Senur. Yeah, all are correct. Great. All are correct. Okay. It is accelerating, right? It is accelerating. If it is accelerating, what is the Newton's law? Newton's second law. Newton's second law. According to Newton's second law, the equation is F equal ma. F equal ma. The mass of the car is 900 kilogram. 900 kilogram. 900 kilogram. The acceleration of object, the acceleration is not giving directly. Yeah, the final velocity 12, then velocity difference is given, right? Velocity difference is 12 minus 0. Initial velocity 0. Divide by time, the time consumption is 8. 8. Now, 912 minus 0 mean 12, right? 900 into 12 over 8, no? Then 12 and 8 cancel. 12 12 divided by 4 it is 3. 8 divided by 4 it is 2. Now 900 divided by 2 it is 450. 450. 450 into 3, 1350. 1350. Right? Midu? Understood? Understood? Okay, before go to next question, if anyone still didn't order the tube, wait, everyone in our July group එකේ කී දෙනෙක් ඉන්නවද දැනට? How many students in our July group? Yeah, 25. එයාලට මම ඔක්කොම post කරලා තියෙන්නේ, right? Everyone posted. If anyone still didn't order the tute, please send me within today, actually. Within today at least, or tomorrow, at least tomorrow, right? Send your address, otherwise I can't send it. Send your address as soon as possible. Send your address because now I have only remain 4 tubes. මෙච්චරමයි ඉතුරු වෙලා තියෙන්නේ, right? I have only 4. I have to inform again, print this tube and post. It's okay. The thing is, you have to order and send your address before tomorrow. Before tomorrow. Before tomorrow. Before tomorrow mean as soon as possible, right? As soon as possible. Then I can inform to print shop, print the number of tubes that we required. Hi. Okay, let's move into question number 9. It's a very good question. A person of 80 kilogram, mass 80 kilogram, falls to the ground. There is a mistake here. Falls down by a parachute. By a parachute pen on it. Parachute, right? By a parachute with a uniform velocity of 3 meters per second. With uniform velocity of 3 meters per second. The resultant force act on this person is, what you think? Clearly read the question and send your answer. Clearly read. Clearly read the question and get the answer. Okay, what do you think? Wrong. Everyone wrong. Sanjana, Prasindu wrong. No, answer number 3 wrong. Answer number 3 wrong. Eh? It's wrong. I even if I wrong. Answer number 2 also wrong. Answer number 2 also wrong. Very good. Now correct. Kalindu correct. Very good. Answer number. Very good. Yes, correct. Yeah. Answer number 5. Why? Using parachute, the person fall with uniform velocity. That's why I told carefully read the question. It is the person fall with uniform velocity. If it is uniform velocity, Newton's second law or first law? Newton's first law. If it is Newton's first law, it is always, this person always balance. If it is balance, there is no any resultant force. There is no any resultant force. Are you good? Okay, this type questions asked in exam. The carefully, if you now you all have idea, I think this the thing is you have to read carefully. Carefully read and understand every words in the question, very important, right? Careful read. A person of mass 80 kilogram falls to the ground by a parachute with uniform velocity of 3 meters per second. The resultant force acting on him, no resultant force, because the person is already balanced. Why he is balanced? Now think without parachute, any person or something fall to the ground. Think this is a ground level. Without parachute, think this is a person. What happened? It's only 80 kilogram. 80 kilogram mean 800 Newton mass. I will explain today why it is 800 Newton. 800 Newton falls into downward. That's we call as weight, right? Weight 800 Newton. And though no any unbalanced force, no any force into upward. But if we use parachute, this is a parachute, then air resistance or upward force by the parachute, right? Then 800 Newton into upward also. That's why there is no unbalanced force. There is no unbalanced force. That's why person fall with uniform velocity. Uniform velocity means 3 meters per second. Uniform velocity. Uniform velocity. If it is uniform velocity, the person is a balanced system. Balanced systems are not accelerating and no unbalanced force. Right? Okay. Sanura, clear, right? Okay, final question. This is a A-level question. This is a A-level past paper question. This O-level, A-level past paper question. Wait. This one. 30. 30. Consider the following statements about a certain mass. Certain mass. An object must remain at rest if no resultant force is applied. A force must be applied to change the direction of motion. The resultant force is inversely proportional to the rate of change of momentum. The question asks, what are the true statements? Only A, only B, only C, B and C only, A and C only. Okay, quickly send the answers. Carefully read, Nitira. The thing is, you have to carefully read. Every word is very important. Each and every word in the question important. දාන්න බලන්න. Rashmita wrong. Wrong. Answer number 4 wrong. Hashini wrong. No, 3 also wrong. Sitila correct. Good. Hari. මේක කියන්න. හරි මේ විදිහට යන් අපි. Okay. I will read first statement. You have to send me, is it correct or wrong, right? An object must remain at rest. No resultant force is applied. True or false? True or false? An object must remain at rest. No resultant force is applied. True or false? TOF. TOF. Yeah, definitely it is false. Why? It's wrong. Why? An object must remains at must mean must remain at rest. It is rest to uniform velocity. It is possible to moving also, right? Not rest, not always rest. An object must remain at rest. No resultant force applied. If no resultant force applied, it's a balance. No balance object according to Newton's first law. It is rest object rest, or if it is moving, it is uniform velocity. Moving with uniform velocity, no problem, right? As previous person question, previous this parachute question, right? Yeah, it is wrong. First answer wrong. First statement wrong. It's false, right? Second one, a force must be applied to change the direction of motion. That's correct. Without force, we can't change the direction, right? Without force, we can't change the direction. See, the resultant force is inversely proportional to the rate of change of momentum. That's a Newton's second law. Yeah. Oh, then force scale. Everyone in the first attempts, you all send me it is correct, right? That's why you told answer number 4. Right. It is wrong. It is actually, it is Newton's second law based on momentum method, right? Based on momentum method. But Newton explained the unbalanced force, resultant force, not inversely, it is directly proportional to the rate of momentum change, rate of change of momentum. Among them, the correct statement only B. The correct statements only B. The correct statements only B. Any doubt? Okay, let's move into the today new topic. Okay, what's the final thing we did? We wrote last day. So the momentum and acceleration is kind of with a cell. Yeah, what's problem? So the momentum and acceleration is kind of same. Momentum and acceleration. No. Momentum and acceleration not change a cell. The momentum change rate directly proportional to the make up momentum change rate again momentum change on a speed decker directly proportional to the unbalanced force. That means when increasing the momentum change rate, when increasing the unbalanced force, the momentum change rate also increasing. Increasing. Directly proportional means not same. That making a nappy unbalanced force equal to the momentum change rate. It is directly proportional. Directly proportional means increasing the unbalanced force. Momentum change rate also increasing. Right? Then we can say when increasing the momentum change rate increasing, the acceleration also increasing. Acceleration also increasing. That's correct. But we can't say momentum change rate equal to the acceleration. Right? I say if it is increase the momentum change rate, acceleration also increasing. Right? Not same. Up same can be. Yeah. Okay. Good question. Okay, finally we wrote what's in the short note. What's the final topic we wrote? Newton's second law based on momentum method. Make up one it make. We wrote this one, right? Finally. Yes. Yeah, this is the final thing we did. Okay, the next topic. Next topic. 1 Newton. 1 Newton. 1 Newton. Now correct. Okay. Okay. The new force, any kind of force, standard unit is 1 Newton, right? Now, do you have any idea how we can define the magnitude of 1 Newton? Define how we can explain the magnitude of 1 Newton. 1 Newton. 1 Newton mean 1 N. 1 capital N. 1 Newton. According to Newton's second law, our basic equation is F equal ma, right? F equal ma is our basic equation. Basic equation F equal ma. Think this is an object with 1 kilogram mass. 1 kilogram mass. 1 kilogram mass. If you want to Newton's second law equation F equal ma, right? According to this equation, if you got 1 kilogram mass, accelerate 1 meters per second acceleration. 1 ms minus 2 acceleration, the required unbalanced force is 1 Newton. This is the magnitude of, this is the best way we can magnitude the magnitude of 1 Newton. If you got 1 kilogram object to accelerate 1 meters per second acceleration, the required unbalanced force. Okay, that's definition also I got according to Newton's second law. F equal ma, right? 1 kilogram object to accelerate 1 ms minus 2 acceleration, the required unbalanced force is the what? 1 Newton. This unbalanced force equal 1 Newton. I got 1 kilogram object to accelerate with 1 meters per square second acceleration, the required unbalanced force is 1 Newton. I got Medu. 1 kilogram object, 1 kilogram object, according to Newton's second law, right? 1 kilogram object to accelerate with 1 meters per second acceleration, the required unbalanced force is, the unbalanced force is the 1 Newton. Okay, write down like this. 1 kilogram object, 1 kilogram object, 1 kilogram object to accelerate with 1 ms minus 2 acceleration. 1 kilogram object to accelerate 1 ms minus 2 acceleration. The required unbalanced force is called as 1 Newton. The required unbalanced force is called as 1 Newton. It's called as 1 Newton. Okay, clearly draw this diagram. Clearly draw this diagram. One kilogram object to accelerate with 1 ms minus 2 acceleration. The required unbalanced force is called as the 1 Newton. Right? Okay, and clearly draw the diagram. Right. 1 kilogram object to accelerate with 1 meters per second acceleration, the required unbalanced force, or the required unbalanced force to accelerate 1 kilogram object with 1 meters per second acceleration. Okay, this is the 1 Newton, the magnitude of 1 Newton, the magnitude of 1 Newton. Okay, let's move into next topic, the weight. The weight, capital W. The weight, capital W. The weight. The weight. Capital W. Okay. Do you know, before discuss about weight, do you know what's the meaning of mass? Mass. Mass. What's the meaning of mass? Any idea? Is it same mass and weight? It is same or not? First thing you need to understand, is it same or not? No, it is completely different. Mass and weight. Mass is actually the amount of matters. Mass is the amount of matters. How many molecules? Amount of matters in the substance. That's the meaning of mass. Amount of matters. Amount of matters. That's the meaning of mass. The mass means amount of matters. Amount of matters. Amount of matters. You know me. Mass unit is kilogram, right? Mass unit is kilogram. Its unit kilogram. But what's the meaning of weight? Weight is a type of force. It's a force to the gravity direction. Always weight is the force act towards to the gravity. Weight is a force act towards to the gravity. Then what is the unit of weight? The weight unit is Newton because it's a type of force. It's a type of force. Understand the difference, right? The mass is the amount of matters. Its unit is kilogram, and the weight is a force act towards the gravity direction. Force act towards the gravity. The force act on any object towards the gravity, right? Any object, the weight is a force act towards the gravity. Always weight direction is gravity direction. I will explain that. I will explain that. Now, do you know mass? If you got mass, is it scalar or vector? What do you think? Mass, that means amount of matters, its unit kilogram, standard unit. Is it scalar or vector? It's a physical quantity, no, it's a base physical quantity. Base physical quantity. Is it scalar or vector? Mass. Yeah, mass is a scalar. It has only magnitude, no specific direction. What do you think about weight? Weight is scalar or vector? Is it scalar or vector? Yeah, the weight is a vector because weight is a type of force. Last week I explained all force types are vectors. They have specific direction as well as magnitude as well as specific direction. Always weight direction is towards the gravity. Towards the gravity. That's the weight direction, right? Okay, write down the first point. Write down the first point. The force exerted on object, the force exerted the force exerted on object, the force exerted on object towards to the gravity, towards to the gravity. The force exerted on any object towards to the gravity is called as a weight. It's called as the weight of the object. It's called as the weight of the object. The force the force exerted on object towards the gravity. The force exerted on object towards the gravity is called as the weight of the object. It's called as the weight of the object. The force exerted on object towards the gravity is called as the weight of the object. Weight of the object. Balanda, don't write. Understand the most important thing, right? Okay. Think this is an object. This is an object with mass m. The mass of the object m. And think this is a force weight acting point. Weight acting point. This is the weight of the object. Weight. How we calculate the weight of this object? According to Newton's second law. Now this is unbalanced force. This is unbalanced force. It is the force exerted on towards the gravity. Right? This is unbalanced force. According to Newton's second law, F equal ma. F equal ma. Now force is weight, right? Force is weight. The mass is m. mass of the object m, right? And acceleration, this acceleration in the gravity, the normal acceleration we call as gravitational acceleration. Api me wage any object, this type any object, if we release in the gravity, in gravity field, api me wage object, then me wage any object, if we release in the gravity field, it is accelerating, right? It is accelerating due to the gravity. It is accelerating. The velocity gradually increasing with height. Height එක වැඩි වෙන වැඩි වෙන මොකද වෙන්නේ? The velocity increasing, right? Normally this value we called as gravitational acceleration. It is approximately 10. Actual value is 9.8650 value, right? The approximately, for easy calculation, think this gravitational acceleration is 10. Then that we call as simple g. Then weight equal mg. Weight equal mg. Mass into gravitational acceleration. I got that one also according to F equal ma. According to F equal ma. Do you know what's the name of this force weight acting point? Weight starting point, weight acting point. This arrow, you know, this is a force acting point. According to this one, it's weight acting point. Do you know what is the name of this point? In O-level time, you learn. What's the name of this point? Anyone? Do you remember? What's the name of this point? මෙයාගේ නම මොකක්ද? විහංග? Do you remember? What's the name of this point? No, yeah. Force acting point that has a specific name. It has a specific name. No, Hashid. It has a specific name. No. Perpendicular reaction asal it's another story. Yeah, very good, Dashmita. It is center of gravity. It is center of gravity. The force, the weight acting point of any object, it is center of gravity. Center of gravity. Gravity. The force acting, not force, weight acting point of any object we called as center of gravity, and that's the method. Calculate the weight of any object. The weight equal mass into gravitational acceleration. Mass into gravitational acceleration. Then what is the unit? What's the unit of weight? What's the unit of weight? Mass mean kilogram. Gravitational acceleration. Acceleration ms minus 2. Kg ms minus 2 equal to Newton. It's a type of force. Then it is Newton, right? Weight unit is Newton. Mass unit is a kilogram. Hari, I think you got the difference between them. Hari. The second point. The first point is done, right? The second writing point. The weight acting point of any object. The weight acting point of any object. The weight acting point of any object is called as center of gravity. The weight acting point of any object is called as center of gravity. Within bracket, gravity point. මෙයාට අපි කියනවා gravity point කියලා. Center of gravity within bracket, gravity point. Gravity point. Gravity point. In first lesson, we only discussing about gravity point, but in future lessons, in fluid mechanism, I think you can remember in fluid mechanism we have upthrust force, right? Upthrust force, the force given by the liquid, the upthrust force into upward. Upthrust force. Do you remember upthrust force? Yeah, upthrust force acting point also, it has a name that we call as buoyancy point or center of buoyancy, right? Buoyancy point or center of buoyancy. When we discussing flotation and sinking of object, this gravity, center of gravity and center of buoyancy very important. Therefore, in future lessons in fluid mechanisms, we can discuss center of buoyancy, buoyancy point. Okay, second point is done, right? The second point is the weight acting point of any object is called as a center of gravity, or within bracket gravity point, gravity point, gravity point, gravity point. Okay, can you draw this? Can you draw this with this calculation? Draw this, clearly draw this. Okay. Okay, the weight acting point is the center of gravity, and how to calculate the weight of any object, mass multiplied by gravitational acceleration, gravitational acceleration, gravitational acceleration. Okay, complete, Rashmita, Nithiran, right? Kalindu, okay. Okay, if you got this type object, if you got this type object, it's 5 kilogram object. What's the value of weight? What's the value of weight? Weight equal mg, right? The mass of the object 5 kilogram. And what is the gravitational acceleration? For easy calculation, normally we think the gravitational acceleration 10 ms minus 2. Then 5 into 10 ms minus 2, it is 10 Newton. Kg ms minus 2 mean Newton, not 10, 50. 5 into 10, 50 Newton. 5 into 10, 50 Newton. Okay, any doubt up to now? It's very simple thing, right? According to F equal ma, it is weight equal mg, mass into gravitational acceleration. Okay, what do you think? Think the same object, Valanda, very important thing. This is a slope surface, and this is object. This is object with mass 2 kilogram object. What is the weight direction? What's the weight direction? There are two possible directions. Men making clearly understand what is the weight direction. Is it this direction or this direction or this direction? 1 or 2 or 3? Quickly send. What is the direction of weight? Vihanger. What's the direction of weight? What's the direction of weight? What's the direction of weight? 1 or 2 or 3? Any idea? Good, Vihanger. Others, what do you think? Ashini? Yeah, that's why I told if it is the surface direction, the surface slope or horizontal or vertical doesn't matter. The weight is a force exerted on the object towards the gravity direction. Towards the gravity direction. This is a weight. This is a weight. This is a weight. They are not the direction of forces, right? This is a weight. This is a weight. This is a weight direction. Weight direction. This is a weight. Normally it is, if it is 2 kilogram, it is 20 Newton. 20 Newton. Remember, the weight always perpendicular to the ground level. It is perpendicular. That's why its gravity direction means perpendicular to the ground level, right? It's perpendicular to the ground level. Hari. Examples kila mere kadagam takka. Examples. Clearly draw this. Examples. Examples. Quickly draw. Still we discuss Newton's law. Today I hope to start friction force as well. Before this me, no point you had note down. There are examples for weight. Weight always act toward to the gravity direction. Towards to the gravity direction. No. No point. You had note down this one. Two diagrams. Okay. Complete, right? Nitira? Ashwini? Okay, that's all about weight. The weight is a force exerted on object towards to the gravity. Always it is perpendicular to ground surface, right? Ground level. May horizontal surface the weight direction always perpendicular. That's why it is gravity direction, right? The weight always act towards the gravity direction and it's perpendicular to ground level. It's perpendicular to ground level. And according to Newton's second law, F equal ma, how to calculate the weight? Weight equal mg, mass into gravitational acceleration. Normally in our syllabus, gravitational acceleration we assume as 10. It is actually 9-point value, right? In our syllabus, it is take as 10. 10 meters per square second. 10 meters per square second. And the force acting, the weight acting point of any object we called as center of gravity or gravity point. Okay, that's a summary. I think you can remember. Okay, let's move into our final Newton's law, Newton's third law. Newton's second law is very long session. Come to the final topic, Newton's third law. Newton's third law. Write down the final Newton's law, Newton's third law. Newton's third law. Newton's third law. Okay, Newton's third law, actually you already know. Everyone you know. What's the Newton's third law? It's very simple theory. Every action has reaction. Every action has reaction with same magnitude and opposite in direction. Okay, they are the examples. They are the example. If these two childs push like this, what happened? Both childs go to opposite direction. Opposite direction. That's a reaction. This is action. This is a reaction. Right? Every action has a reaction. There is a reaction equal to the magnitude and opposite in direction. Hurry. Write down. Write down. Every action, there is an reaction. There is a reaction. Every action, there is a reaction. Every action, there is a reaction with same magnitude and opposite in direction. With same magnitude and opposite in direction. Opposite in direction. Opposite in direction. With same magnitude and opposite in direction. Opposite in direction. Same magnitude and opposite in direction. Very important thing. Think this is a table, right? Think it is a surface of a table. It's a surface of a table. Surface of a table. And there is an object on the table with mass m. With mass m. There is a force act. This is a gravity point. There is a force applied to the gravity direction that we call as weight. Right? Weight equal mg. Mg. If you got 5 kilogram object, m equal 5 kilogram into gravitational acceleration, weight equal 50 Newton, right? 50 Newton. Now, if it is 5 kilogram and it is stable on my hand, stable on my hand. If it is stable, how it is stable with only gravity force? How it is stable? Not only gravity force, there is an reaction force as well. That's why it is stable. Without reaction force, it is not stable. It is fall to the ground, right? The reaction force given by the surface we called as perpendicular reaction. It is capital R. It is perpendicular reaction. Perpendicular reaction. Perpendicular reaction. Perpendicular reaction. Perpendicular reaction. Perpendicular reaction. Okay, do you know what is the magnitude? The perpendicular reaction also 50 Newton. The perpendicular reaction also 50 Newton. That's why the weight 50 Newton, the perpendicular reaction also 50 Newton. This is the action, the reaction equal to the magnitude and opposite in direction. I got equal in magnitude and opposite in direction. This is a Newton's third law application. Every action has reaction with same magnitude and opposite in direction. I got. This is a one application of Newton's third law. Altaf, understood? Rashmita, Asel. Asel, this is a perpendicular reaction, right? Make a perpendicular reaction. It is always given by the surface. The perpendicular reaction given by the surface, not by object. The object given force towards the gravity, it is weight. Object given force is a weight. The surface given force is a perpendicular reaction. Perpendicular reaction. Perpendicular reaction. Not only that, there is another application. Think it is a supporter and sorry. There is a string, and this is an object hanged by a string. Object connected with string. Right? It is 1 kilogram. What's the weight of 1 kilogram mass? It is the force exerted to the gravity. It is weight equal 10 Newton. 10 Newton. Then if it is balance object, there is a reaction force. There is a reaction force with equal magnitude and opposite in direction that we call as tension. It is tension. It is capital T. Capital T means tension. Tension. Without tension, it is fold out, right? This object hold balance due to this tension force. The tension force equal 10 Newton, equal magnitude and opposite in direction. Okay, that's why we call every action has reaction in same magnitude and opposite in reaction. Understood? Okay, this is a Newton's third law. Newton's third law. What we wrote finally, Azir? Newton's third law definition, right? Another Piliwe, Kalindu? I forgot. Only definition, good. Okay, they are the examples. You can draw the example. First one, it is tension. Capital T tension, capital R perpendicular reaction. Perpendicular reaction. Okay, complete. Okay, Newton's law. The second main topic is completed. Newton's law and all questions also we discussed in tutorial. Okay, let's move into our third main topic. Third main topic. Okay, you complete, right? Ashini, done? Okay, Nitira, are there? Rashmita, have you done? Okay, okay. Now, in our content of the lesson, the first part, the basic of forces and Newton's law. The second topic is done. Okay, let's move into our third main topic, friction force. I think you got a lot of new things now. All level time also you doing Newton's law and force balance and unbalanced force systems, right? You got a lot of new things in our only within Newton's law part, right? Okay, the next one is a very important part. That one also you doing in all level time, right? You did in all level time. Okay, this is the third main topic, friction force. Friction force. Third main topic, friction force. Friction force. Friction force. Okay, do you have any idea what's the meaning of friction force? What's the meaning of friction force? Any idea what's the meaning of friction force? What's the meaning of the friction? Friction. Friction is a resistant force. The friction is a resistant force that's given by the surface always. Friction is a resistant force that given by surface. That's the most important thing. Sometimes you're doing mistake. The friction force, you think friction force exerted by the object. No. The friction force completely given by the surface. That's the first thing you need to remember, right? The friction force is the resistant force given by the surface. Think this is an object with mass m. If you applied an external force of F, the friction force is a resistant force given by the surface. The F dash, the resistant force given opposite direction by the surface. The friction force always given by the surface, right? The friction force always given by the surface. This part also you doing very new things, very clear understanding within today, right? I will explain everything in friction force and basic things within today, and advanced final part we can discuss next day maybe. Other current very important, right? Today part very important in friction force. Okay, write down the first point. First point. A resistant force given by the surface. A resistant force given by the surface on object. The resistant force given by the surface on object. while applying an external force. While applying an external force. While applying an external force. The resistant force given by the surface on the object while applying an external force. While applying an external force is called as friction force. Is called as friction force. Is called as friction force. It's called as friction force, right? Again, check your definition. A resistant force given by the surface on the object while applying an external force. While applying an external force is called as a friction force. Okay, this is a friction actually. It's a resistant force and given by the surface. Given by the surface. Okay. There is an object. There is an object on my hand. Is there any friction act on this object? Is there any friction act on this object? Yes or no? This is an object on my hand. Think my hand is a surface, right? Is there any friction act on this object? Oh, yes or no? I need your response. Stuck out here. We don't have time. Yes or no? All are wrong. The friction act on this object, 0. The friction act on this object, 0. Okay, that's why I told you in all level time you're doing only background of each lesson. Then right? You're doing clearly all lessons in this syllabus, in our syllabus. Okay, the friction force act on this object, 0. Remember. Think there is an object on the surface. There is an object on the surface. Is there any friction force? No friction force. No friction force. Now think this is a rough surface. Make a try to get full story of this part. Then you can easily understand entire lesson. Now think this is a rough surface, right? This is a rough surface like concrete surface or little bit rough surface. And there is an object on this rough surface. There is an object on this rough surface with mass m. Right? Clearly asked, right? The target. And there is no any unbalanced force. There is no any external force. Then friction 0 actually. No friction force exerted on this object. Right? That's why in the definition, after this story, you can read again definition and try to get the understand, right? Okay, now I am going to apply. Think it is 5 kilogram object, 5 kilogram object, right? Now I am going to apply 5 Newton external force on this object. Then what is the friction force? Think this object is still not moving. This object is still not moving. Then what's the friction force? Then now this is object. Now I have applied 5 Newton force. Still the object rests. What's the friction force now? What's the friction force? What's the friction force? Still not moving. Still rest. What's the friction force? But I have applied force. Force එකක් දාලා තියෙනවා. 5 Newton force. What's the friction force? Remember 5 Newton is a force. 5 Newton is a friction force. Why? Newton's law. Newton's law. But 5 Newton external force is still object rest. If it is object rest, it is balanced or unbalanced object. It is balanced object according to Newton's first law. I got. Then friction force also 5. You got Newton's first law. Yes or no? Any doubts in me? Yes or no? Now 5 Newton object, right? If there is no any unbalanced force, මෙහෙම තියෙද්දි there is no any friction force, right? I am going to apply 5 Newton external force on this object. Still object rest. Object rest mean what happened? Object rest mean it is balanced, no? According to Newton's first law, no unbalanced force, therefore friction force also 5 Newton. Can you agree with me? Altaf? Sinon? Hurry. Think, now I am going to increase this applied force up to 10 Newton. Clearly understand. Okay, think I am going to increase the applied force. I am going to increase applied force up to 10 Newton. Still object rest. Still rest, not moving. Then what is the friction force? Then what is the friction force? Then what is the friction force? Still object rest. Still object rest. Then friction force in also getting 10 Newton because object balance. Object balance. Object balance. Okay, think I am going to increase the external force up to 15 Newton. 15 Newton. 15 Newton. 15 Newton, right? I am going to increase the external force up to 15 Newton. මෙන්න මෙතනදී still object rest. Still object rest. Then what's the friction force? Friction force also getting 15 Newton because Newton's first law. Rest object no any unbalanced force. Rest object is balanced. If it is balanced, applied force equal to the friction force. Onna katha, right? Think, this is the most important thing. Think this 15 Newton is the maximum friction force that can given by the surface, right? This is a maximum friction force that can given by the surface. This maximum value, surface to surface, this maximum value is depending, right? Surface to surface, this maximum value is depending. Api hitamu, assume this surface, the maximum friction force 15 Newton, right? 15 Newton. Okay, if I apply 16 Newton on this object, 16 Newton, I am going to apply 16 Newton on this object. Then what happened? The maximum friction force 15. Yeah, start to moving, right? Start moving into this direction. Start moving into this direction. What do you think? That's the most important thing. What do you think? What is the friction force act on this object? It is 15 or less than 15 or greater than 50. එතකොට මෙන්න මෙයාලා කියන්න මට. එතකොට friction force එක I have applied 16 Newton. Right? It is 15 or 16 or 14. What's the friction force? Hashini, what do you think? No, you all answers wrong. Sorry, neither wrong. Others, what do you think? Now the maximum friction force that can given by the surface, this surface is 15 Newton, right? Now I am going to apply 16 Newton. එතකොට maximum එකට වඩා දෙන්න බෑ. That's okay. Yeah, remember, while object moving, this friction force getting slightly less than the maximum value. While object moving, the friction force getting slightly less than the maximum value. Okay, practically you can feel this actually O level time you did only background. That's why I told you. In O level time, every lesson you only doing in O level time you did definition of friction. Harina, and three types of frictions, no, limiting, dynamic, and statics. And what are the definitions of limiting? මේ වගේ full idea එක දෙන්නේ, right? You only doing the background and basic things, right? Basic story. Okay, but now in our syllabus in A level, it's not enough this basic knowledge, right? You should have complete idea. Now I told you, if you apply external force greater than maximum value, the maximum 15, if you apply 16 Newton, the friction force getting less, slightly less than, slightly less, it's very small difference, slightly less than the maximum value. And if I apply 20 Newton, what do you think? What's the friction force? If I apply 20 Newton, what's the friction force? If I apply 20 Newton on this object, external force, what's the friction force? Hashini, Jeniru, what's the friction force? No, how you call 10? No. Again, no changing. It's again no changing. It's a constant value. While object is moving, the friction is constant. It's no changing. Then 100 Newton applied into external force. That case also friction force 14 Newton. I got. Any doubt? Do I need to explain that? Who? Vinuji, I got. Meedu. Yeah, okay, I'll explain. Good. Okay, now think this is a object, right? If there is no any unbalanced force, there is no any external force applied, the friction force 0. That's okay. It is no unbalanced force, it's 0. Friction force 0. If I applied 5 Newton, very small force, if it is still raised, if it is object still raised, if I apply force and object is still raised, then friction force equal to the applied force. 5 Newton, 5 Newton, 10 Newton, 10 Newton, 15 Newton, 15 Newton. Okay. But if we increase the applied force greater than the maximum value, 15 maximum, if we increase applied force greater than the point this maximum value, okay, maximum value, what happen? Object start moving. May start, right? Move. At the moving stage, the friction force slightly less than the, it is not exactly 14, right? I got example. It is slightly less than the maximum friction force. Slightly less. And it's this, while object moving, this slightly less friction force, it's a constant value. It's a constant value. Now, okay. Others? In O-level time, you did friction force mainly 3 types, no? What are the types? What are the types? Static friction force, static friction force, limiting friction force, and limiting friction force and dynamic friction force. Do you remember? Yeah, static friction force, dynamic friction force, and limiting friction force. The second one limiting, static, limiting, and dynamic. All right. Now I will explain very simply, what are the static, limiting, and dynamic. Okay, in the static friction force mean still object rest state is a static friction force. In the static friction force, the applied force equal to the friction force and object already balance. Object balance mean object rest. You know, all rest objects are balanced. All rest objects are balanced. Therefore, applied force equal to the friction force. No unbalanced force. Therefore, object rest. That's why we called as static friction force. Static friction force, right? The limiting friction force, remember the limiting friction force is the maximum friction force that can given by the surface. The maximum friction force can given by the surface. That totally depend on the surface type. If you got rough surface like concrete surface, its limiting friction force is greater. If you got tile or very smooth surface, the limiting friction force is very low value. It's totally depend on the surface nature that we discussing in future parts, right? The limiting friction force is a maximum friction value that can given by the surface, right? According to our example, 15 is the limiting friction force. මෙන්න මේවා තමයි static, right? They are the static. They are the static. I think now it is simple, right? They are the static. They are the limiting, right? And while object, if we applied external force greater than this limiting friction force, greater than this maximum friction force, the object start moving. The object start moving. While object moving, the friction force act on this object we called as a dynamic friction force. And dynamic friction force is a constant value. No again variations. Dynamic friction force. Now, if you have any doubt, you can ask. No doubts? Vihenga? Chiniru? Sanjana? Everyone okay, right? Amishka? Okay. Write down the next topic. Types of friction force. Types of friction force. Types of friction force. Types of friction force. Types of the friction force. Okay, write down the first point. Depending on the situation, act on the object. Depending on the situation, act on the object. Friction forces, depending on the situation, act on the object. Friction forces, mainly three types. Friction forces, mainly three types. Friction forces, mainly three types. Write down first one, static friction force. The second one, limiting friction force. Third one, dynamic friction force. Static friction force. Second one, limiting friction force. Third one, dynamic friction force. Static friction force, limiting friction force, and dynamic friction force. Write down the first subtopic, static friction force. Write down the first subtopic, static friction force. Static friction force. First point. First point. First point, the friction force equal to the friction force equal to the applied external force. The friction force equal to the applied external force. The friction force equal to the applied external force. Second point, since there is no unbalanced force, since there is no unbalanced force, since there is no unbalanced force, object stays rest. Object stays rest. Since there is no unbalanced force, object stays rest. Within bracket, Newton's first law. Newton's first law එකකින් කිව්වේ ඒක තමයි. Newton's first law. Newton's first law. Right? Newton's first law. Write down the second subtopic, limiting friction force. 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 First point, the maximum friction force, the maximum friction force that can given by the surface. The maximum friction force that can given by the surface. The maximum friction force that can given by the surface. The maximum friction force that can given by the surface. The maximum friction force that can given by the surface. Second point, this is totally depend on the nature of the surface. This is totally depend on the nature of the surface. This is totally depend on the nature of the surface. Okay, surface nature I will explain in the next part. Okay, then this is totally depend on the nature of the surface, right? Okay, come to the third 1. Third subtopic, dynamic friction force. 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 The first point, dynamic friction force, first point. If apply external force, if apply external force greater than the limiting friction force, if apply external force greater than the friction limiting friction force, if apply external force greater than the limiting friction force, comma, the friction force act on the object, friction force act on the object, the friction force act on the object, comma, the friction force act on the object getting slightly less than the limiting friction force, getting slightly less than the limiting friction force, getting slightly less than the limiting friction force, getting slightly less than the limiting friction force. Complete first point? Anyone not complete? Getting slightly less than the limiting friction force. If applied force less than the limiting friction force, the friction force act on the object slightly less than the limiting friction force. Now, final point, the second point. Since there is an unbalanced force, since there is an unbalanced force act on the object, since there is an unbalanced force act on the object, object accelerating, object accelerating, within bracket Newton's second law, within bracket Newton's second law, within bracket Newton's second law, within bracket Newton's second law. Okay, can you rapidly draw this one? Quickly draw this. This is the okay, we have another 5 minutes. අපිට graph එක තන්ට එක්මන් කරමු. Quickly draw this. Okay, this is the static friction force. Static friction force. Sorry. Last point again. Since there is an unbalanced force act on the object, since there is an unbalanced force act on the object accelerating, the object is accelerating. Since there is an unbalanced force act on object, the object is accelerating. The object is accelerating. මේ තව point එකක් තියෙනවා, final point. The dynamic friction force is a constant value. The dynamic friction force is a constant value. the dynamic friction force is a constant value. මේ බලන්න එයා constant. Okay, this is a static, this is a limiting, that's a maximum limiting, and this is the dynamic. This is a dynamic. Okay, they are the applied force, external force, applied force කියලා applied force. Clearly draw this. In the next graph you can get the full idea. Make up daga. Okay, can you draw this within 2 minutes? Now almost 9. Please send me your address and order your tube pack within today or tomorrow. Otherwise, very difficult to manage. I have to print again because now almost printed. This time I printed 100 tubes. Then mangaw තියෙන්නේ 4යි. Okay, I want to get the actual count for our physical class. Almost everything okay, but your class is a problem. I need the actual count. Order within before tomorrow, right? Okay, done. Senora. Basindu, complete. 2 minutes done. Nitira. Evan. Right. Okay. Now let's try to graphically represent. I mean, graphic. I think you already know in O level time. let's try to graphically expression these relationships. This is the friction. This is a yeah, applied force. Applied force, external force, right? Applied force. This is a friction force. This is a friction force. Friction force. Now think, understand. Okay, the applied force gradually increasing. The applied force gradually increasing, right? Then what happened? The think 5, the friction force also 5. If we increase to 10, the friction force also 10. If we increase external force up to 15, the friction force also 50. 50. I got. Now this is a maximum. This is a maximum value that can given by the surface, that means limiting friction force. And this is the dynamic friction force. It is slightly less than the limiting friction force, and it is a constant value. It's a constant value. It's a constant value. It's slightly less than the limiting friction force, and it is constant value. According to our example, it is 40. I mean, it is 40. I got, and it is constant value. Api meya 20, 25, 100, any applied force, the dynamic friction force is a constant value, and it is slightly less than the limiting friction force. Then you can name, this is a static friction force. This is a static friction force. This is the limiting, that's a maximum limiting friction force, and this is the dynamic, the constant one, dynamic friction force. Understood? Now you can get the full idea, right? Clear? Okay, note down. That's a graphically expression of friction force changes. Graphically expression of friction force changes. Okay, right? Everything okay? Do you have any doubt from today class? That's a today lesson. Any doubt from today lesson? No? Okay, this is a dynamic friction force, right? Dynamic friction force is slightly less than the limiting friction force. Maximum point is a limiting, right? And it is slightly less than the limiting friction force, and it's a constant value. It's a continue constantly. Okay, let's discuss applications and further about friction force in next day. Next day also we're doing very important part, final part of friction force, and we're discussing, I think in O level time you didn't study about friction force calculation. තිබ්බද නැද්ද? නෑනේ. F equal mu r, F equal mu r කරාද? F equal mu r, yes or no? Asil? No. Next week we start friction force calculation as well as uh, force resolution, the most important part. The force resolution, force, how to force divide into several parts, right? Force resolution, that is very new part, no, not it in O level. Okay, and the thing is, you have to, if you don't have this tute and not ordered yet, please order and send your address and with it before tomorrow. And the next thing, if you already ordered, don't send me again. While July group එකේ ඉන්නවනම් ඔක්කොම post කරලා තියෙන්නේ. Everything posted, and you can check tomorrow morning. If you not received, you can check tomorrow morning in your post office. The other thing, yeah, if you not ordered, please send me your address. Yeah, that's all. Let's meet with the next part of force lesson next Sunday. Goodbye. Good night.